Hello friends, welcome back to Advanced Mathematics 2. Friends, in the last session we have discussed about Laplace transform, right? How we are going to define a Laplace transform mathematically. It means we can write down the definition of a Laplace transform in the form of integration limits 0 to infinity e raised to st f of t dt. And suppose if I want to calculate the Laplace transform of any function, I have to verify the sufficient condition. Then only I can say that a function is eligible for the Laplace transform. And after that we have discussed about change of scale property of a Laplace transform. And what is the first shifting property? Transform of derivatives. And I think yesterday at the end of the session I have given what do you mean by a periodic function, and I think I have solved some examples about all those things. Is it clear, right? So I am going to repeat the definition of a periodic function. Is it clear, right? A function f of t is said to be periodic with the period omega if f of t plus n omega is equal to f of t. Is it clear? So n being any integer, or we can say that a function is a periodic of its values repeat at regular intervals. Graphically, this means that if the graph of f is shifted horizontally by omega units, is it clear, the new graph is identical to the original. In this notation, period means that for all t in the domain of t, that is f of t plus omega is equal to f of t. It means when you draw the graph of periodic function, so you will get a similar to original graph. Then this graph will move horizontally either side of the x axis, or you can take t axis. The smallest positive constant omega for which this relationship holds for all values of t is called period of t. I will show you the graph. Is it clear? I hope now you are observing two graphs. One is a red color graph, another one is a blue color graph. So red color graph is the original function sin t. Is it clear? And sin of t plus some value is the blue color graph. I hope now you are observing blue color graph is moving horizontally. Is it clear? Left hand side as well as right hand side. That is an example of a periodic function. Exactly in the similar way, suppose if they ask us to sketch the graph of the periodic function defined by f of t is equal to t minus n, right, where t lies between n and n plus 1 with the period 1. It means that you can replace n by 0. So what you will get, f of t is equal to t. Is it clear? Right? So where t lies between n and n plus 1 means it lies between 0 and 1. I hope you are observing bar lines, red color bar lines. Is it clear? Right? Starting from origin, right? And it lies between 0 and 1. Is it clear? It lies between 0 and 1. And similarly, second red color line is lies between 1 and 2. Is it clear? And similarly, next line is lies between 2 and 3. Is it clear? How it is possible? In the given function, you have to replace n by 0, 1, 2, 3 and so on. Is it clear? So then you will get this type of graphs. Is it clear? Difference between first line and second line is 1. Similarly, difference between second and third line is also 1. It means period is 1. That line is shifting, right, on either side of the t axis. It is also an example of a periodic function. Right. So another example may be in this form. Write down a mathematical expression for the function whose graph is shown. Is it clear? Right. So why I am considering this type of example? Because so once we are able to write down the mathematical expression of this type of graphs, then concept will be very clear. That's why we should practice how it is possible to write down the mathematical expression for this type of graphs. Is it clear? Right? So observe the graph. All the color graph looks like similar. Is it clear? Right? So when you observe a violet color graph, it is passing through origin. Actually, it is containing two straight lines, one in between 0 to 1, is it clear, and 1 to 2 is a horizontal line corresponding to 1 on y axis or on f of t, is it clear. It means suppose if I want to define this graph mathematically, I need two intervals, is it clear. So, one is in between 0 to 1 and 1 to 2, is it clear. Like that I can define a function in the following form, is it clear, right. So, we want to note down that the interval over which the function represents itself, repeats itself is 2, is it clear. So, 0 to 1 and 1 to 2, it means period is 2, is it clear, right. So, it is then sufficient to describe the function over any interval of length 2, is it clear. The simplest interval to take is 0 to 2, is it clear. It means t lies between 0 and 2. We note in this example that a single formula is insufficient to describe the function for 0 is less than or equal to t is less than 2, since different behavior is exhibited in the two intervals, namely 0 is less than or equal to t is less than 1 and 1 is less than or equal to t is strictly less than 2, is it clear. For 0 is less than or equal to t is less than 1, it means interval is 0 to 1. The function is a ramp, is it clear, with slope 1, is it clear. Now, what I have shown in the previous slide, right, in between 0 and 1, that line we may call it as an ramp with slope 1 passes through the origin, is it clear. That is it has an equation f of t is equal to t, right. For 1 is less than or equal to t is less than 2, the function value remains constant at 1. I hope now you are able to write down the function. You observe, therefore, this periodic function can be described by the expression f of t is equal to t, where 0 is less than t is less than 1, is it clear, and f of t is equal to 1 and 1 is less than or equal to t is strictly less than 2 with the period 2, is it clear. I hope just now you have observed a moving a similar type of curves, it is coincides with the existing curves, is it clear, right. So, if you want to, you can write down an individual mathematical expression for each and every curve, or you can write down an general mathematical expression, then you can use this slide. So, it will move on either side of the t axis, is it clear, right. So, I wanted to give one more similar type of example, and it is a very famous example, right. So, sometimes they may give a graph like this, write down a mathematical expression to describe the function whose graph is as follows, is it clear. Now, observe the graph, right. So, corresponding to 1 on f of t, so small line segment is there, and from 1 to 2 on the t axis, again you can see the small line segment, is it clear. Suppose if you copy these two line segment and if you paste, is it clear, right, on the xy plane or f of t plane, is it clear. I hope it repeats once again with the violet color, and if you copy violet color graph once again, I hope you can see a red color graph. It repeats in the similar fashion, is it clear, right. So, when you join 1 to 1, is it clear, 1 to 1 means say for example on f of t 1 is there, no, from that line to t axis 1 is there, no, if you join those two, I hope it will form a square, is it clear, right. So, now I want to write down the mathematical expression for this graph. How I am going to write down, you will come to know. So, periodic function can be described by the expression f of t is equal to 1, because it lies between 0 and 1. If you write 0 to 1, so I hope you will get a line segment, is it clear, right. So, in between 1 and 2 it is 0 with the period 2, is it clear, right. So, you can consider a similar type of example, write down the mathematical expression to describe the function whose graph is it clear. I hope you are observing the graph, it is like a triangle, is it clear, right. So, from origin to 1, you observe the graph, from origin to 1 blue color triangle is observed, is it clear. Actually, it is containing two line segments, right. So, from 0 to 1 by 2 or 0 to 0.5 is one segment, 0.5 to 1 is another segment. Is clear? And similarly, 1 to 1.5 is one line segment and 1.5 to 2 is another line segment. Is clear? Exactly in the similar way, you can observe a violet color triangle from 2 to 2.5, 2.5 to 3. Is clear? It means these graphs containing two line segments. Is clear? When you consider either violet color or blue color. Is clear? So, blue color is repeating after certain period. Is clear? Here what is the period? Period is 2. So, now you want to write down mathematically. How you are going to write down mathematically, right? You can write down in various forms. F of t is equal to 2t, where 0 is less than or equal to t is less than or equal to 1 by 2. Is clear? And another line segment can be write down 2 minus 2t between the interval 1 by 2 to 1. Is clear? And one more triangle can be write down 2t minus 2, right. So, interval is 1 to 3 by 2, 4 minus 2t, 3 by 2 to 2. Is clear? And the last triangle can be write down 2t minus 4, interval is 2 to 5 by 2, 6 minus 2t, 5 by 2 to 3, right. So, I have written particular triangles. Is clear? Right. So, if you do not want to write repeatedly, you can write down one general equation, right, including n or any other constant, then you can vary n. Is clear? I hope you can draw the triangles. Friends, so just now we have discussed examples about periodic function. Now we want to discuss one important property of periodic function. Is clear? Right? So, if f of t is periodic with period omega, then we can prove that Laplace transform of f of t is equal to 1 divided by 1 minus e to the power minus s into omega in the interval 0 to infinity e raised to minus st f of t dt. Hence, evaluate where f of t plus 2 is equal to f of t and f of t is equal to 1. 0 is less than or equal to t is less than 1. 0, 1 is less than t is less than 2. It means first we want to prove left hand side is equal to right hand side. Then you want to use it as a formula to find out the Laplace transform of the given function. Here what is the given function? 1 to 0 between interval 0 to 1 and 1 to 2. Is it clear? It means they have defined a function in the interval 0 to 2 and they have given a function is a periodic function. Why? F of t plus 2 is equal to f of t, right. We can say that it is a periodic function. Is it clear? I hope now you are observing the square wave graph. Is it clear? Right. So, you can find out the Laplace transform of a square wave graph. Is it clear? Now, first we can prove left hand side is equal to right hand side. How we are going to prove? It is very simple. You know the basic definition of Laplace transform. Is it clear? Right. So, L of f of t is equal to integration of 0 to infinity e raised to minus st f of t dt. Is it clear? So, this is the basic definition of Laplace transform. Right. So, now I am going to split integration of 0 to infinity in the following form. In the following form means I will rewrite it as integration of 0 to omega e raised to minus st f of t dt plus integration of omega to 2 omega e raised to minus st f of t dt. Is it clear? And I hope you can expect a next term. What is the next term? If you want, you can write down integration of 2 omega to 3 omega e to the power minus s into t f of t dt and so on. You can write down up to infinity. Is it clear? Right. So, now I am going to add all the terms, sum of all the terms, first term plus the second term, third term and so on. Right. So, that is equal to what you will get? You will get summation from n is equal to 0 to infinity, integration of what is the lower limit? N omega. What is the upper limit? N plus 1 omega e to the power minus st f of t dt. Is it clear? right? Here I am going to use a method of substitution. Suppose if I put t is equal to n omega plus x, and if I differentiate, what you are observing a red color letters, is it clear, right? If I differentiate t is equal to n omega plus x, what you will get, dt is equal to dx. I hope limits will change. Put t is equal to n omega. What is the value of x? N omega minus n omega. It means you will get x is equal to 0. Suppose if you put t is equal to n plus 1 into omega. Is it clear? So what will get, x is equal to omega. Is it clear? And they have given a function is a periodic, f of n omega plus x is equal to f of x, right? So I am going to implement in the equation. I will rewrite above equation, summation of n is equal to 0 to infinity, limits from 0 to omega, e to the power minus s into, I will replace t by its value. What is the value? N omega plus x into f of n omega plus x into dx. Is it clear? So that is equal to summation of 0 to infinity, integration of 0 to omega, e to the power, I will multiply minus s into n omega. Is it clear? Into n into e to the power minus s into x, integration of f of x dx. Here we want to integrate with respect to x. Is it clear? That is why I can treat e to the power minus s into omega into n as a constant. That is why I want to write down outside. Is it clear? Right? So now I am going to write down L of f of t is equal to summation of n is equal to 0 to infinity, e to the power minus s omega into n outside. Within the bracket, I will write the remaining things. What is the remaining things? Integration of 0 to omega, e to the power minus s into x into f of x dx. Is it clear? Right? So before integrating, now I want to calculate. So what is the value of summation of n is equal to 0 to infinity, e to the power minus s into omega into n. Is it clear? Suppose if I replace n by 0, so what you will get? I will get 1, because e to the power 0 is 1. Right? So if I replace n by 1, I hope I can obtain e to the power minus s into omega plus e to the power minus times of 2 into s into omega plus e to the power minus times of 3 into s into omega, and so on. Is it clear? And it can be written as 1 divided by 1 minus e to the power minus s into omega. So you may ask, how do we get 1 divided by 1 minus e to the power minus s into omega? So because you know the geometric series, right? So a is the first term, ar is the second term, ar square is the third term, and so on up to infinity. It can be written as a divided by 1 minus r if modulus of r is less than 1. Is it clear? So using geometric series, summation of e to the power minus s into omega into n can be written down 1 divided by 1 minus e to the power minus s into omega. I will substitute in the above equation. Is it clear? So therefore L of f of t is equal to 1 divided by 1 minus e to the power minus s into omega. Is it clear? Within the bracket, integration of 0 to omega e to the power minus sx f of x dx I have written as it is. Is it clear? So that is equal to 1 divided by 1 minus e to the power minus s into omega, integration of 0 to infinity e to the power minus st f of t dt. Is it clear? So here x is a dummy variable, t is a dummy variable. I can change x to t. Is it clear? I hope you will get the required equation, right? So that is the required equation. So now I want to find out the Laplace transform of a square wave function. Here we have omega is equal to 2. It means by considering omega is equal to 2, now I want to find out what is the Laplace transform of the square wave function. I hope you are observing the diagram. That diagram we may call it as a square wave function. Is it clear? Right? So L of f of t, it means Laplace transform of f of t. Here our function is the square wave function, that is equal to 1 divided by 1 minus e to the power minus 2 into s, because I have replaced omega by 2 within the bracket integration of 0 to omega is there, no? Omega can be replaced by 2 e to the power minus st into f of t dt, that is equal to 1 divided by 1 minus e to the power minus 2 into s, integration of 0 to 1, because I want to split 0 to 2 to 2 parts. So, you can observe the graph, is it clear, right? First part is 0 to 1, is it clear, I think blue color line, and second part is 1 to 2 on the t axis, is it clear. I want to integrate these two parts. I can integrate the first part, second part is 0 because t becomes 0, it is on t axis only. So, that is why, so you can write down e to the power minus st into 1 dt plus 1 divided by 1 minus e to the power 2 omega, sorry 2 times of s into integration of 1 to 2 e to the power minus st 0 into t. Is it clear? So, automatically second term becomes 0, right. So, now I want to integrate only first part. Is it clear? So, that is why what I have written 1 divided by 1 minus e to the power minus 2 into s, integration of 0 to 1 e to the power minus st into 1 dt. Is it clear? I hope we can integrate e to the power minus st with respect to t. So, treating s as the constant, integration of e to the power minus st is what? E to the power minus st divided by s. Now, I want to substitute the limits. Is it clear? Right. So, t is equal to 0 to t is equal to 1. So, what we will get 1 divided by 1 minus e to the power minus 2 into s, e to the power minus st divided by minus s, with the limits t is equal to 0 to t is equal to 1. I hope I can obtain 1 divided by 1 minus e to the power minus 2 into s. Is it clear? So, when I replace t by 1, I hope I can obtain e to the power minus s. Is it clear? So, when I replace t by 0, it is e to the power 0, that is why I will get 1. It means numerator is e to the power minus s minus 1 whole divided by minus s. So, remaining part is simplification. You can multiply 1 into e to the power minus s minus 1 whole divided by minus s into 1 minus e to the power minus times of 2 into s. Is it clear? The same thing can be written as minus times of 1 minus e to the power minus s, because you can take out a negative sign outside in numerator. Is it clear? What is the denominator? I have written minus s into the bracket 1 minus e to the power minus s into the bracket 1 plus e to the power minus s. It is just like a square minus b square. Is it clear? It can be written as a plus b, a minus b, right. So, one term will cancel with the numerator, because numerator and denominator containing the same factor. Is it clear? You can write down the remaining thing. What is the remaining thing? 1 divided by s into 1 plus e to the power minus s is the Laplace transform of the square wave function. How we have calculated using the previous property. Is it clear? Right. So, if you want, you can draw the diagram of square wave function. Is it clear? Now, I think in the last in the last session, I have given how do we draw the graph of a Laplace transform using an software like GeoGebra. Is it clear? Simply you want to type the square wave function. I hope you can obtain the corresponding Laplace transform of the given function or square wave function. Is it clear? I hope now we have discussed about periodic function and the property of a periodic function, and we have discussed one example about a periodic function. Is it clear? So, now I want to continue in the similar way, and I can introduce one more important concept in Laplace transform, namely unit step function, right. So, friends, you may ask what you mean by an unit step function. Is it clear? Right. The unit step function, also called Heaviside unit step, right. So, then you may ask what do you mean by Heaviside. I hope in the present slide you are observing one photograph. Is it clear? Right. So, what you are observing, his name is Heaviside. he introduced this function first time. Now onwards we call it as an unit step function. Is it clear? How you are going to define a unit step function? It is very simple. You can write down u of t is equal to 0 when t is less than 0. So you may ask, what do you mean by t? T is a variable. Here we will call it as an time, right? When time is less than 0, what is the value of the function? Is 0. When t is greater than or equal to 0, what is the value of the function? It is 1 only. Is it clear? Right? So this unit step function is a curve which has value 0 at all points to the left of the origin and equal to 1 on the right of the origin. It means that when we draw the graph of u of t, is it clear? Right? So I hope you can draw y-axis and x-axis. Is it clear? Left hand side, the value of the function becomes 0. Right hand side, the value of the function is 1. Is it clear? Right? So it means it maintain the height 1 unit. That's why it is called an unit step function. Is it clear? Observe that at t is equal to a. A is what? A is some constant. A step of unit height is formed. Hence the name unit step function. Right? So we can use various notations to represent unit step function. Is it clear? Other notations to represent unit step functions are h of t. You can use capital H of t or capital H of t minus a, or u suffix 0 of t, or u suffix small a of t. So these are the few notations of unit step functions. Suppose if you want to denote an unit step function, right? So you can denote in the following form. Is it clear? Just a minute. So once you are able to denote an unit step function, right? Okay. So graph of unit step function. Now as I have mentioned, when t is less than 0, you can observe this graph. T is less than 0, it is 0. When t is greater than 0, t is greater than 0 means time is greater than 0. I hope you can observe it is maintaining a red color line corresponding to 1 on f of t. That is called an unit step function. Is it clear? Right? Now mathematically you can define u of t. I have already defined it. So exactly in the similar way you can define a displaced unit step function. How we are going to denote displaced unit step function? U of t minus a. The displaced unit step function u of t minus a is defined as u of t is equal to 0 when t is less than a. A is what? A is some constant. Is it clear? Or u of t is equal to 1 when t is greater than or equal to a, where a is greater than or equal to 0. Right? The displaced unit step function u of t minus a represents curve u of t, which is displaced or translated, or sometimes you can say that shifted a distance a units to the right of t axis. Is it clear? On the t axis, suppose if you give a is equal to 1, it will shift 0 to 1. Suppose if you give a is equal to 2, then it will shift 0 to 2. If I give a is equal to small a is equal to 4, then curve will shift 0 to 4. So like that it will shift. Is it clear? Right? So when you practice this type of graphs, I hope very easily the concept of unit step function will be understood. Is it clear? Right? So for example, sketch u of t minus 3, u of t 6 times of it is u of t minus 2. Is it clear? Right? Now first one, u of t minus 3. Just now I have mentioned we want to shift the curve, right? When the value of a is 3, Is it clear, right? So it is as good as u of t minus a, right? I hope you are observing unit step function is shifted, what I have written with the violet color, u of t minus 3. Is it clear, right? It is shifted from 0 to 3. It means up to 3 it is 0, 3 onwards it is 1. It is maintaining height with 1 unit. Is it clear? Now exactly in the similar way, or before that, it is like a switch. I can use one more word instead of reading it as a u of t minus 3. I may call it as an it is like a switch, right? Electric switch. If t is less than 3, it is off. When t is greater than or equal to 3, it is on. Is it clear, right? The function will work like a on and off. Is it clear? Now exactly in the similar way, you can draw the graph of u of t. It is as good as a unit step function. When t is less than 0, so it is 0. When t is greater than or equal to 0, then you will get the corresponding curve. Is it clear? And it is denoted by so u of t, right? Now exactly in the similar way, now you can draw the curve of 6 times of, actually it should be u of t minus 2. Not I think it is printed 6 times of t minus 2. It is not 6 into t minus 2. Actually it should be 6 times of u of t minus 2. Is it clear? What you are observing in violet color, it is correct. Is it clear, right? So it means you can draw the curve u of t minus 2. T minus 2 means it is shifted to 2. Is it clear, right? So when we are multiplying with 6, no, that's why it is maintaining the height 6 units instead of 1 unit. It is maintaining the height 6 units. That can be observed. Suppose if you multiply by 5, you know, it is maintaining the height 5 units. If I multiply by 4, it is maintaining the height 4 units, and so on. Is it clear, right? Suppose if I want to write an example like this, is it clear? Sketch EduChart program 20 into u of t minus 3. Is it clear? Or suppose if I want to draw the graph of MATDIP401 into u of t, how we are going to define these two live examples? Is it clear? EduChart P20 means EduChart program 20 into u of t minus 3. MATDIP means mathematics, advanced mathematics for diploma 2 into u of t. How we are going to write down mathematically? It is very simple. So you can write down EduChart P20 into u of t. Is it clear, right? Is equal to 0 when t is less than 3. Is it clear? EduChart P20 when t is greater than or equal to 3. Here t means time. It means before 3 o'clock. Is it clear? EduChart program 20 is off. You cannot get the signals. Is it clear? At time t is equal to 3, I hope you can receive the signals. Is it clear? Right? Namely EduChart P20. Exactly in the similar way, suppose if you are planning to watch mathematics, advanced mathematics 2 lecture. Is it clear? How we are going to define MATDIP401 into u of t is equal to 0 at time t is less than 3. It means it is not possible to see when the time is less than 3. Is it clear? So you can see the lecture MATDIP401 at t is equal to 3. Is it clear? Right? So it is an analogy. Analogy means you can compare. Is it clear? Instead of writing EduChart P20 or MATDIP401, I can write down a function. Is it clear? You can remove EduChart P20 and MATDIP401, right? Then you can write down any function what I have written in this slide. F of t into u of t is equal to 0 when t is less than 3. F of t when t is greater than or equal to 3. So like that you can write down. Is it clear? I am planning to give one more live example. Is it clear? Right? Say for example, if you want to listen a radio, it means if I want to on a radio at time t is equal to 1 p.m. Is it clear? Right? And similarly, I want to on a television at t is equal to or at time is equal to 3 o'clock. Is it clear? I want to on a computer at time t is equal to 4 o'clock. So how we are going to write down this situation using a unit step function? Is it clear? So what we are observing with black color statement. Is it clear? So radio into u of t minus 1. It is understood that so radio will on at time t is equal to 1 plus television or TV into u of t minus 3 means at 3 o'clock television will on plus computer into u of t minus 4 at 4 o'clock computer will on. Is it clear? How we are going to represent in the form of a function. Is it clear? Right? So you can write down, you can take any general function, say g of t is equal to 0 at t is less than 1. It means if time is less than 1, radio is off, right? Television is also off, computer is also off. Is it clear? Right? So at time is equal to 1, radio will on in between 1 p.m. and 3 p.m. Is it clear? And similarly, radio plus TV will on in between 3 and 4 p.m. Is it clear? And last one is radio plus TV plus computer will on at t is equal to 4 onwards. Is it clear? So like that you can define. Is it clear? Right? So I want to extend the same example. Is it clear? So I want to on radio at t is equal to 1. I want to off a radio on TV at t is equal to 3. Why I want to off radio? Because it is a national waste. I don't want to waste the power. Is it clear? And we can't use all the 3 equipments at a time. Is it clear? So that's why I can rewrite above example in this form. I want to repeat once again. I want to on radio only at t is equal to 1, and I want to off radio on TV at time t is equal to 3. Is it clear? Again I want to off TV at 4 o'clock and on computer. Is it clear? So how I am going to write down using a unit step function. Is it clear? So there are 2 methods. Method 1 is radio into the bracket u of t minus 1 minus u of t minus 3. Suppose if you write like this, u of t minus 1, it means at 1 o'clock radio will on, minus u of t minus 3 means automatically it will off at 3 o'clock. Is it clear? Plus TV into u of t minus 3, right? It means television will on at 3 o'clock minus u of t minus 4 means at 4 o'clock television will off. It means we want to kill the television signals at time t is equal to 4 o'clock. Plus I want to on computer at t is equal to 4. How we are going to write down? Computer u of t minus 4. Is it clear? So this is one method, right? So we can write down the same thing by using another method. Is it clear? So in method 1, some common unit step functions are there, namely u of t minus 3, u of t minus 4. Is it clear? Right? Instead of writing repeatedly, so you can use the method number 2. Is it clear? Right? So radio into u of t minus 1. It means radio will on at time t is equal to 1. Is it clear? Plus TV minus radio. TV will on, radio will off at time t is equal to 3. That's why I have written into the bracket u of t minus 3 with the red color, plus computer minus TV within the bracket. Computer will on, TV will off at time t is equal to 4. That's clear. Again it is an analogy, right? So you can replace radio and television, computer by any 3 functions. That's clear. So for example, radio can be replaced by F1t at t is equal to 1. That's clear. And television can be written as F2t at t is equal to 3. Computer by F3. That's clear. So like that you can define F1, F2, F3. It means a single function can be split into 3 parts. That's clear. It means more than one part. Right. So unit step function u of t or displaced function u of t minus a, is clear, are extensively used to represent a portion of the curve of the function f of t, are explained in the following cases. It means a unit step function can be written down in 3 different forms. Is clear, right? So say for example they have given f of t. Now I want to multiply by an unit step function. What is the resultant function? Is it clear? So f of t is multiplied by unit step function u of t. The resultant function f of t into u of t will represent the part of the function f of t on the right of the origin. The part of f of t on the left of the origin being cut off. It means vanishes for t is less than 0. It means when t is less than 0, left hand side curve is not visible, only right hand side curve is visible. Is it clear? Suppose I can demonstrate y is equal to sin t into u of t. They have given sin t into u of t. Is it clear? Or they may ask us to sketch y is equal to f of t is equal to sin t. I hope you are observing the sine curve. Is it clear? Red color curve and unit step function. Is it clear? I am going to multiply these two curves. Then what is the resultant curve? I hope you cannot see the left hand side curve. Is it clear? How you are going to write down mathematically? Sin t into u of t is equal to 0 when time is less than 0. That is equal to sin t when t is greater than or equal to 0. You observe the curve, left hand side sine curve is not visible. It means it becomes 0. Is it clear? Our right hand side curve is only visible. Is it clear? So this is one type of a unit step function. Right? So exactly in the similar way, sometimes if they ask us to calculate or if they ask us to draw the graph of f of t into u of t minus a. U of t minus a means a displaced unit step function will represent the part of the function f of t on the right of t is equal to a. The part of the function f of t on the left of the t is equal to a cut off. Is it clear? Right? So you can see both the graphs. One is a unit displaced function. It is varying. I have given some values for a. That's why curve is moving on either side. Is it clear? And y of t plus 1, a straight line passing through the 1. When I multiply these two graphs, what I can obtain? I can obtain the curve after the 2 time t is equal to 2. Is it clear? Right? How we are going to define mathematically? U of t minus 2 into t plus 1 is equal to 0 when t is less than 0. Is it clear? It means when t is less than 2, graph is not visible. Is it clear? When t is greater than or equal to 2, then it is visible. Is it clear? So that can be observed. Okay. Exactly in the similar way, sometimes they may ask us to draw the graph of sin t into u of t minus pi. Is it clear? Right? So again you can draw the displaced function u of t minus pi. Is it clear? And I have also drawn sin t curve. Now I want to multiply these two curves. Is it clear? Right? So what is the resultant function? Resultant function can be written on u of t minus a represents on switch at t is equal to pi. It means at t is equal to 5, curve is visible. Is it clear? Less than 5, curve is not visible. So mathematically you can write down sin t into u of t minus pi is equal to 0 when t is less than 5. Is it clear? So that is equal to sin t when t is greater than or equal to pi. Right? So you can observe the graph on the t axis when the value of t is less than pi. You can observe at t is equal to 0, at t is equal to pi by 2 and up to pi. Right? So curve is not visible. Is it clear? Right? It is on the t axis. After pi, I hope you can observe the sine curve. That is the resultant function. You can take one more example. Say for example, y is equal to t square. I want to draw the curve of t square into u of t minus 1. Is it clear? Again t minus 1 is a unit displaced function. Is it clear? Right? So you can draw the graph of y is equal to t square. I hope we have obtained a red color graph. Multiply these two graphs. What is the resultant graph? Is it clear? Right? So u of t minus 1 represents on switch at t is equal to 1. It means at time t is equal to 1, so it will on, otherwise it will be off. That's why mathematically you can write down t square into u of t minus 1 that is equal to 0 when t is less than 1, or t square when t is greater than or equal to 2. Observe the graph on t axis. When t is less than 1, curve is not visible. Is it clear? When t is greater than, part of the t square curve is visible. Is it clear? That can be observed from the graph, right? Or I can demonstrate, sketch y is equal to t minus 2 into t minus 2. Actually, what do you mean by minus 2? Is it clear? Either in t minus 2 or u of t minus 2. I can say that it is a shift of 2 units on the right hand side. Is it clear? Suppose if I write t minus 2, curve will shift 2 units to the right hand side on the t axis. Suppose if I write t minus 3, is it clear? So what do you mean by t minus 3? Curve will shift 3 units on the right hand side. Either it may be t minus 2 or u of t minus 2, t minus 3 or u of t minus 3. According to that, curve will shift either 2 units or 3 units. What we will write? Original function is t into u of t. Is it clear? Right? So here it is given that y is equal to t minus 2 u of t minus 2. Now first we can sketch the graph of y is equal to t. Is it clear? I hope you can observe the first curve, a straight line passing through the origin. Is it clear? What is the second step? Translate y is equal to f of t is equal to t, 2 units to the right hand side. Is it clear? You can observe the second graph, right? T axis, f of t axis, and you can observe the straight line u of t minus 2 into t minus 2. It is shifted from origin to 2 units. Is it clear? Right? So suppose if you want to write down mathematically, you can write down t minus 2 into u of t minus 2. Right? Suppose if you want to sketch y is equal to sin t into t minus 5 into u of t minus 5. Is it clear? Instead of 2, here I have considered 5. So sine curve graph we are already familiar. It is shifted from 0 to pi. Is it clear? Right? So what you are observing, shifted by pi units. Is it clear? Original curve is sin t into u of t. Right? So suppose if you want to sketch t minus 2 whole square into u of t minus 1. First you can draw the curve of t minus 1 whole square, then u of t minus 1. T minus 1 whole square means the original curve is t square. Is it clear? And that curve will shift 1 unit because we have written t minus 1 whole square into u of t minus 1. You can observe the second curve, it is shifted from 0 to 1. Is it clear? On the t axis. Right? Suppose the portion of the curve, third type of unit step function is the portion of the curve f of t lying between a and b. If you want to visit f of t in between a and b, where a and b are what? A and b are some constants. How we are going to write down? U of t minus 2 minus u of t minus 4 is equal to 0 when t is less than 2, is equal to 1 in between 2 and 4, is equal to 0 when t is greater than 4. I hope you can observe the curve. U of t minus 2, u of t minus 4 is visible, other part is not visible. Is it clear? Sometimes they may ask us to sketch sin t u of t minus 2 u of t minus 4. It can be write down 0 when t is less than 2, sin t between 2 to 4. Observe the curve, it is visible only 2 to 4. Is it clear? Right? So friends, exactly in the similar way, the curve is visible in between 2 and 4. Is it clear? Right? Here curve is visible in between 0 to pi by 2. Right? Now I hope you can practice like this. You can draw any curve. Curve is visible in between 1 and 2. Is it clear? Right? So I have defined all the types of unit step functions. Is it clear? So now you can find out the Laplace transform of unit step function. L of u of t is equal to, you can use the basic definition, replace u of t by 1. I hope you will get 1 by s. Is it clear? Or Laplace transform of unit displaced function u of t minus a, 0 to infinity can be written as so 0 to a to infinity. First part is 0, second part is 1. Again you can integrate. I hope you will get e to the power minus as by s. This is clear, right? And third one is second shifting property. Second shifting property means L of f of t is equal to f of s. This is clear, right? So u of t minus a into f of t minus a is equal to e to the power minus as f of s, right? It can be verified so by using the basic definition. This is clear. Now you can find out the Laplace transform of unit step function. This is clear, right? Or f1t, f2t, how they have defined f1 and f2t on the basis of f1 and f2t. So you can express in the form of unit step function what I have explained in case of radio, television and computer. Exactly in the similar way you can write down in this form. Then it may be 2 parts or it may be more than 2 parts. It can be expressed in the similar way, right? So now we can find out the Laplace transform of unit step function. Is it clear? Sin t u of t minus 4, right? So I hope you will get the solution. Or the given function may be in this form, f1t is t square, f2t is 4t. Is it clear, right? So first you want to express in terms of unit step function, then you will get the Laplace transform of each function. Using the formula you can find out the solution. So what you are observing in the last session. Friends, I take this opportunity to thank the VTU authorities for giving me an opportunity to learn a lot of things. I also thank Mr. Ravi and other technical persons. So thank you very much.